on. So that is what state updates. And iterative process means one by one it will check. The message passing process is repeated, refining nodes, states until a stable configuration is updated. The last one, convergence, what it will do during the message passing is convergence. The iterative updates continue till the system reaches convergence. That means all together convergence, ensuring efficient communication. So this is the message passing. So applications of GNNS. So where and all it is used in research, especially in computer science, not only in computer science, all the fields are using this one. That means all to convergence, basically efficient communication. This GNN, the neuro evolution, and the combination of this applications of GNI, machine learning, so where and all it is used. It's particularly used in especially in computer science. Not only in computer science, all the fields are using this one. Social networks, convergence, basically nowadays social network analysis, data mining, evolution, for example, and the combination of this applications of GI, particularly used in computer science, social network analysis, all the fields are using this one. All understanding convergence, basically nowadays in social networks, the evolution, for example, and combination of the applications of GI, particularly used in computer science, social network analysis. Just suddenly we can use this one in what your this type of GNNs in your chemistry also to predict the molecular property by analyzing graph representation of molecules, enhancing drug discovery and material science, traffic protection. So much traffic survey. So what will be the traffic load on the road after 1 hour or after 2 hours, like that, whether it is good to travel through the road, we can plan it based on it. So GNS improve traffic flow prediction by modeling urban transport networks, aiding in congestion management and smart city planning. So in future, we are planning for smart cities, and there and all, this GNS are you going to use for what? The traffic prediction. So recommendation systems, as I already told you, which one can be used or not, like the recommendation system. Utilizing user item interaction graphs, GNS enhance the accuracy of recommendation in e-commerce and streaming platforms. So this is the neuro evolution benefits. So in here, we are combining what neuro evolution with the GNNs. That's the topic, no? So special, what is neuro evolution? And we are what is GNNs, everything. Now it is nothing but what with the GNNs, how the neuro evolutions do. The performance, enhancing. To enhance the performance, we can call this as for the hybrid also. Enhancing performance and adaptability through integration method. That is integrating, joining together, joining ants. So that's a symbol as shown in the diagram also, the figure also. It's joined actually. So what can be done with this combination or combining these two things? One, optimization of GN architectures. That is, evolutionary algorithm can refine the structure of GNN. That is hybrid. Already we have neuroevolution, and we know the thing what in GNNs. So using this evolutionary algorithms can refine the structure of GNNs, improving the overall performance. Number two, improved generalization. A synergetic approach leads to better generalization capability in various tasks, enhancing outcomes. Increased efficiency, the output. The output means what? The output by input like that, we are getting the output, 100% output like that. The integration optimizes resource use, making GNS more efficient in processing complex data. If you're just going for a combination of the things. Next one, adaptive learning. Neuroevolution enables GNS to adapt to new data patterns, maintaining a relevance with overtime. You just see this is the combination of what your neuroevolution. This is a very important research topic area. So those who are just doing are going for what we are registering with PhD. You can just take down these topics, no? So how to go for your optimization of GNN architectures, improved generalization, increased efficiency, adaptive learning. All are there actually. The only thing which one should be combined to what? That one is going to be the work for you, and you can compare with the old one, and you can just give the results to the universe. So this is the thing, case study, especially in healthcare. So exploring the impact of neuroevolution and GNNs in healthcare applications. So now lot of things are taking place in healthcare, and a lot of computer applications are working. That is, we are just every day we are bringing some application which is used for the healthcare, because a lot of diseases are the throughout the universe. So what we can do with this combination, that one, you can go for what, predicting patient outcome. So predicting patient outcome utilizes data patterns for forecast health trajectories and enhance care. So we can predict based on the prediction. We can go for what it can be diagnosed whether it will come or not, whether it will be dangerous or like that. Based on that, we can go for what, taking the drugs discovery, and we can just get cure about it. That's what I'm telling. It's predicting patient outcomes. A drug discovery accelerate the efficiency, that is identification of potential drug candidates through advanced simulations. Personalized treatment plans. Personalized treatment, we can just take what a one person, we can find what is there in his body, and we can give a special type of a treatment to that, so that we can call it as what, the tireless therapies based on individual pattern data for optimal results. So you just see, this is in case of what, the healthcare. You go for your neuroevolution, GNNS combination working a lot. Case studies in finance sector. So this will be useful for what the finance people know. So the accounts that people are exploring the impact of deep learning technologies in finance. So fraud detection we can find using this one in what, deep learning. Deep learning models analyze transaction patterns to identify anomalies, helping prevent financial fraud. We can do it. Predicting market trends, machine learning techniques forecast market movements by analyzing ways, that is vast amounts of financial data and trends. And credit scoring, advanced algorithm assess credit worthiness by evaluating numerous variables, improving loan approval process. Just see. So these three things are very important in what the financial sector. If you use this one, no, the combination of all the things and getting into what deep learning, no, so we can just solve all this thing called the fraud detection, predicting market trends, and credit scoring. So this is very important, no, this in this juncture, everyone, those who are having some what do you call the term in bank sectors, the savings, or they go for some investments, that and all. It's very important for individual, no. So we have to safeguard that one. So for using this type of technologies, we can just get a good results. Then case study technology. So the technology means exploring these two things. Optimizing network infrastructure. So we need it actually optimize. A lot of connections are there that should be optimized. Utilizing neuro evolution algorithm to enhance network performance, leading to reduced latency. That is the lag in the data, latency, and improved user experience. We can do it. Enhancing recommendation systems, implementing graph neural networks to provide personalized recommendations, increasing users' engagement and satisfaction. Thirdly, improving cyber security measures, that is, applying deep learning techniques for anomaly detection, ensuring robust protection against cyber threats. So that is this. These are the technology applications. Current trends in neuro evolution. This the people those are going to do research are doing research, no. So you can just get hold of it. So where and all we can use this neuro evolution. So basically, I'm just showing what are three important, no. So where you can use this neuro evolution. The first one is nothing but auto ML. So ML, everybody knows it is nothing but you can go for automated machine learning, that is auto ML, This automated machine learning simplifies the process of model development, making machine learning more accessible. It automates hyperparameter tuning and model selection, improving efficiency. So the machine learning, automated one. So neuroevolution, we can use it. Neuroevolution augmenting topologies, NEAT. This is very updated. That is what SAFER is very important one in nowadays. Neuroevolution of augmenting topologies NEAT. NEAT is a genetic algorithm for evolving neural networks, allowing for complex architectures to be developed dynamically, enhancing problem-solving capabilities. And thirdly, increased use of reinforcement learning. Reinforcement learning has gained traction for its ability to learn optimal policies through trial and error method, leading to advancement in robotics. So this increased use of reinforced learning is used in what advances in useful, very useful in advancement in robotics, and especially the people those who are game liker. So they you can go for what game playing for it. This is current trends in neuro evolution and current trends in what GNNS. So the growth, you're just able to see the graph, that is the arrow mark showing what the growth. So you're able to see graph attention networks, GATs. So current trends, GATs, graph attention networks. GAT utilize attention mechanism to improve node representation, adapting to graph structures. That is called GAT networks. The next one is called scaling GNNs for large graphs. Recent technique focus on optimizing GNNs to handle a larger graph effectively, enhancing performance. And final, multitask learning with GNNs. The GNNs are increasing employed in multitask learning, allowing simultaneous learning of related tasks. So this is hello.
Yes, sir. Audible, sir. Yes, sir.
It's audible.
Yes, sir. Yes, sir. You are audible,
It's
sir.
audible. Some disturbance are there. Hello. Shall we go ahead?
Sir, I
Hello.
will check, sir. I will check. I will check.
I'm audible, ma'am.
Yes, sir. You are audible, sir. You are audible, sir.
Okay, okay. So you're just able to see what this slide no. So indicating. So what are the trends in GNNS? Advantages of neural or neuro evolution. So what we why for we learning this one? Okay. So to get what that's useful things can be done or buy from it, you can get it. That is advantages. So exploring key benefits in advanced deep learning techniques, automated architecture search, adaptability to complex tasks, potential for discovering novel solutions. So in this way, we have what lot of advantages of what your neural evolution, that is efficiency. This allows for optimized architecture without manual usage. Without manual usage. So you can just get a proper design, enhancing efficiency, we can get it. Adaptability to complex tasks, neural evolution excels in dynamic environment, adjusting to diverse changes and evolving strategies to meet complex materials, complex tasks like that you can take. Potential for discovering novel solutions. This approach encourages creative problem solving, often leading to innovative solutions that traditional method might. So these are the advantages. Advantages of GNS. So yeah, what GNS excel at processing complex relationships within data, making them ideal for social networks. So when you go for social network, if the person is doing research in what social networks, he or she should touch this GNNS. So surely the person doing uh, the research in social network with what type of application it is, she or he should know this neural networks, graph neural networks. Then only their work will become what easier to find what the problem actually it is there, how it can be solved like that. So GNS excel at processing complex relationships within data, making them ideal for social networks and knowledge graphs. That is scalability to large data sets. Scalability to large data sets. Say, for example, then you'll be having what GNNs are designed to work effectively with non-SDN data structures. I told you what is the UCDN data. I already told you. Enhancing applications in various fields like chemistry and biology. So we are going for interdisciplinary. So using this GNNS, we are going to get enhanced applications in finding the structure of a chemical or the biological system that can be done. The performance of what non-Euclidean data. The second one, that is the last, that handling relational data, and this one, scalability to large data sets. These networks can efficiently scale, allowing for the analysis of vast data sets without a loss of performance. Able to see what the three important advantages of your GNS. One is handling relational data. Number two is scalability to large data sets. The third one, performance of non-Euclidean data. So challenges in neural, whatever advantages is there, very easy or it is difficult. That is it. But there will be a lot of challenges in what neural evolution. No, the people those who are doing research in this one, just note down all this. Computational cost plays a very important role. Disability you have to study. Computation cost is high. High computational resources are essential for effective neuroevolution, often limiting accessibility for small problems. If you are going to take what your work as a very small work and the project is going to be seems to be very small also, the investment for this type of research will be what very high. But if you just go for it, surely I'm just telling the result will be obvious. That is, it will be what very good. Scalability issues. Scaling neuroevolutionary algorithm can be complex, making it difficult to apply them to large data sets or real world problems. So it can be scalability issues is there. But anyway, if you just do your research in such a way, your work is going to be like that. If the scalability issues can be eradicated and you can just get apply to them what a large data sets and real world problems. But anyway, there is some challenges in it. So we can come across that also if you work on it. Defining fitness function, where you have to fit, that is very difficult actually. And establishing appropriate fitness function remains a challenge as they critically influence the success of evolutionary strategies. So these are some what you call the challenges in neuroevolution and challenges in GNNs. When you have what challenges in neuroevolution, surely there will be some challenges in what GNNs, but this and all can be cleared and you can get what a combination of the things will be what enhanced application, like the enhancing application. Scalability to large graphs, that is, GNNs offers struggle to process large scale graph due to computational limitation, affecting the performance. Number two, handling dynamic graphs, adapting to changes in graph structure in real-time presence, significant changes for GNNs, impacting their adaptability. The third one is efficient message passing. That is also a very challengeable thing in what GNNs. So it won't go properly from one node to the another node. So automatically the efficiency will get decreased. Optimizing message passing mechanism in GNNs is crucial for maintaining speed and accuracy during node interactions. So these are the challenges in GNNs. So future direction in neuroevolution, reducing that is challenges, that is directions, the work where you can go. So reducing computation costs, that is, as a researcher, you people has to go for a new algorithm. So writing a new algorithm or finding or involved, that is inventing a new algorithm that requires less processing power can enhance efficiency in neuroevolution. So this also you can take as a research work. So that is new work in new evolution, enhancing scalability. So that is size, the scalability size. Creating scalable models allows neuroevolution technique to handle large data sets for problem effectively. And the third one, what we can do, integrating with other AI techniques. So the world is actually integrating everything with what the AI model, no, that is AI techniques, the same thing they're telling. Combining this neuroevolution with methods like reinforcement learning could lead to more robust AI systems. Future direction for ANS, lot of things. Developing more efficient algorithms. Research will focus on creating algorithms that optimize processing time and resource usage, enabling larger scale application. Handling dynamic and heterogeneous graphs, future studies will aim to improve GNN's ability to adapt to changing structures and diverse data types in real-time scenarios, enhancing interpretability. Efforts will be made to develop methods that make GNN's decision-making processes more transparent and understandable users. So these are the future directions in GNNs. So you can just note down this one for your research works. The potential advancements in deep learning. That is what you are just the topic. No, that both in what deep learning. That's the, just doing that one. Exploring innovations in neural exploration and GNN's integration, and this is called as what a deep learning. So everything have been done in deep, and so potential advancements in deep learning. Improved integration of neuro evolution and GNNs. It should be what very depth. We should have a improved integration of neuro evolution and GNNs means what? Like that, we have to go for developing an algorithm. The existing algorithm is there. It is giving some output by what some 60 or 80 or 85 like that. Now it's giving output. Now, as a researcher, as we are the researchers, we have to incorporate in such a way that we have to bring a hybrid algorithm to get what a improved integration of these two techniques. That's what I'm telling you. This advancement aims to enhance the synergy between these two fields, enabling more robust learning algorithms. That is what mechanisms. Then enhance automation in AI model design. So we have to make it that one. Future tools may allow for automatic generation of models, reducing human intervention and speeding up development. Last, that is the greater interpretability and transparency, focusing on making AI decision more understandable can build trust and facilitate better human collaboration. So we are collaborating these two techniques in what the deep learning, real world applications where we can use healthcare innovations, financial security, and technological advancement. I already we discussed this slide before that, what we can do. So it can be used in real world. It can be used in healthcare. That means lot of issues are there. We can take that as a problem and you can work it as a real world problem, and we can just give the output as what real world application. Financial sector is there. Financial loss we can prevent it. We can predict it. We can save it like that. So technological advancement, implementing network optimization technique to improve data flow and reduce latency. So this is the real world applications of what this two things. In conclusion, so just adding a lot, this slides no actually. So we learned about what is the neuro evolution and what is meant by this GNN, how it can be combined and when it can be called as what this deep learning that is done. So based on that, no. So I'm just moving for the conclusion over here. Optimization of neural network design, that is neuro evolution techniques enhance the structure or performance of neural networks, making them more efficient for various applications. So like that, you should have a neural network design should be optimized like that. The strength of graph neural networks, that is what are adept at processing relation data, enabling better conceptual understanding in complex data sets. Like that, you should have a graph. The strength of the graph neural system should be like that. So combinations, range of these two things. Combination of these two techniques results in advanced tool capable of tackling intricate problems effectively. Applications in deep learning together, they provide robust solution across diverse fields, enhancing capability in machine learning tasks. So this is the conclusion after just knowing. This is the question and answer session. So you can have that understanding neuro, that is understanding neuro evolution, explore how neuro evolution optimizes neural networks, enhancing performance and adaptability. Neural networks, discuss the neural networks, discuss the significance of GNN in processing, so structured data, particularly in deep learning, application in deep learning, identify real-world applications where neuroevolution and GNNs deliver superior results, and future trends speculate on future developments in neuroevolution and GNNs impacting AI landscapes. So references, these are the things I did actually, references, some books, some things like that, no papers, right? And this is about our presentation. Thank you.
Thank you so much, sir. Participants, any queries,
Yes.
please? Any queries? Okay. Hope there is no queries. Thank you so much, Dr. Vijay Chakravarti, sir, for your comprehensive and thought-provoking session. Your insights into neuroevolution and GNN and real-time and scalable deep learning have provided us with a deeper understanding of these complex yet crucial areas in AI. Thank you so much, sir.
Participants, participants are requested to turn on your video mode for the group photo session. Please kindly do needful. Before starting the next section, participants are requested to turn on the video mode. Participants are requested to turn on the video mode, please. Thank you, sir.
Participants, please take a moment to turn on your cameras.
Thank you all. Thank you all for your photo. Turn on your video. Thank you.
Thank you, participants. It's my great pleasure to introduce our distinguished resource person for the second session, Dr. Joy Long Song Chen, a distinguished professor in the Department of Electrical Engineering at Dao University, Taiwan. With an impressive academic career, Dr. Chen is renowned for his contributions to electrical engineering, especially in the area of signal processing, wireless communications, and neural network applications. We are honored to have him with us today to share his extensive expertise and insights. I welcome Dr. Joy Long Song Chen to lead this session. Over to you, Professor.
Okay. Do you hear me? Do you hear
Yes,
me?
sir. Yes, sir. Yes, sir.
Okay. Ladies and gentlemen, this is Joy Chen. I'm from Dao University, Taiwan. Okay. I will share some the technology with you, all the people and all the friends. Okay. This is my experience of lectures. I know is the distinguished professor, Department of Electrical Engineering, Dao University, Taiwan. And I have some the project now in the is running. And my area of specialization was the machine learning, IoT development, wireless communication, all TM systems, and WSN wireless sensor networks experience. I have the experience in preaching and research about 24 years. Okay. Today, I will show you with the agenda about deep learning, challenges of machine learning, and many fields of deep learning. Also, deep learning techniques, some deep learning techniques, and the importance. I will introduce some of the importance of CNN architectures. And there I will have a project and share with you. Okay. It is known that deep learning is no longer going to the field of medical image analysis. It is a growing trend and the demand for deep learning to achieve as you know how the human brain works, where it comes to data and recognize pattern for decision making. With the rest of technology and the better algorithm, more machines provide high accuracy and reliability for medical analysis. The detection of cancers or malignant cells is crucial for the treatment of lung cancer. Deep learning application of image analysis to computed tomographic CT images helps detect malignant cells before they develop and become lethal. Deep learning has been shown to have significant performance in image processing, especially in object detection and location. Deep learning uses multiple layers to represent data abstraction to build computational models. A deep learning algorithm with convolutional neural networks is applied to a data set to perform classified classifications task. And every year, medical imaging provides indispensable in saving numerous lives by assisting physicians in detecting and diagnosing a diverse range of illnesses, such as cancer, pneumonia, stroke, and heart diseases. The significance of early non-invasive diagnostic detection has led to a rise in scientific funding. Bioimages serve as the primary data source in healthcare. They also pose the significant challenges when it comes to analysis. Currently, healthcare professionals heavily rely on overburdened with radiologists to perform medical image analysis, occasionally even analyzing scanning themselves. Nonetheless, the analysis of medical data heavily depends on human specialists, but it has inherent limitations caused by subjectivity, the complex nature of the image, variance among interpreter, and fatigue. Despite continuous improvements in medical imaging technology. So, also, false negatives are less common. Their consequences can be devastating. The remarkably elevated rate of false positives can be attributed, at least 11 in part, to radiologists' apprehension about overlooking diagnosis. Detecting disease at a later stage versus treatment expenses and lowers survival rate. Automated analysis utilizing the latest deep learning algorithm is already it increases results at a significantly better rate compared to manual process. As this automated system becomes increasingly prevalent in the healthcare sector, they have the potential to bring about transformative shifts in how both radiologists and patients utilize imaging technology to monitor treatment and enhance outcomes. Artificial intelligence comprises several branches, one of which is machine learning. That seeks to understand how data is organized and create models that humans can understand and utilize. While it belongs to the realm of computer sciences, machine learning sets itself. Apart from traditional computational approaches, instead of reading on pre-programming instruction for calculation or problem solving, computers can gather information from data inputs thanks to machine learning. Algorithm machine which then use statistical analysis to produce output values that fall within a predetermined range. As a result, machine learning streamlines the process of constructing model from data samples, facilitating automated decision making on input data. And in order to fully capitalize on the advantages offered by machine learning in medical imaging, it is imperative to tackle the following aspects. First, developing machine learning algorithm for evaluating new image is a complex task that involves advanced learning algorithm and prevent substantial quantities of clinical. And next, machine learning model do not learn on incremental basis. There is little done on a real-time basis. Healthcare organization that rely on learning with most tech algorithms, computer-aided design algorithm focus on particular task or conditions, making it challenging to develop algorithms that can be universally applied across various scenarios. And next, despite the existence of image analysis and decision support projects for a considerable time, a significant number failed to progress beyond the initial pilot stage. And the next algorithm can detect unusual image objects, but they lack the ability to elucidate the underlying reasons or furnish radiologists and more specific information, resulting in what is often referred as the black box effect. And next, I will introduce some of the benefits of the deep learning. Given the following reason, a lot to gain by integrating deep learning and the CAD application into their operations. As they demonstrate great potentials. And first, compared to radio-based deep learning has the ability to access a vast array of images available at a significantly faster pace and with greater consistency. Next, the algorithm enable experienced radiologists to make decisions and enhance their education. And the third one, by employing paid radiologists and can delegate repetitive reading and management duties to automation, thereby allowing them to dedicate their attention to patient interaction research and intricate cognitive processes. Also, by utilizing deep learning, the radiologist workflow can be automated, prioritizing time sensitive caches and placing them at the top of the work disk. Also, the next utilization of machines holds immense potential to significantly enhance diagnostics accuracy, prevent medical errors, and decrease excess testing. And next, deep learning has the potential to serve as an advanced clinical decision support tool in the field of registry. It can provide register with capabilities such as segmentation, classification, and pattern recognition, which in turn can offer valuable guidance based on statistically significantly finding for image analysis when it comes to analyzing image. Subjective interpretations can vary widely, but machines can step in to eliminate subjectivity and reader discrepancies by providing quantitative measurements and ultimately enhancing potential outcomes. And next, I will introduce some of the deep learning techniques. First, I introduce the RNN, recurrent neural network, RNN. RNN is a widely used type of neural network that operates on sequential or time series data, which the output from the previous stage is used as input to the current stage, while feed forward and the CNN networks learn from training input. Recurrent network possess the unique characteristic of memory. They may use this memory to store information from past input, which affects both the input and the output at that moment. RNN generates output by taking into account the components that came before it in the sequence. In contrast to typical CNN deep neural networks that assume independence between inputs and outputs. Nonsense. Standard recurrent neural network face challenge with vanishing gradients, which impede their ability to effectively learn long sequence of data. This is the disadvantage. Next, I say something about the GNN, generative adversary network. A GNN is an architectural design of a neural network capable of producing realistic samples upon request. The process entails the automatic detection and the acquisition of the fundamental pattern or consistency within the input data, enabling the model to generate fresh examples based on the original data set. Two neural networks which makes up the GAN generator, and which that creates new data is reasonable to the original data, and a discriminator that evaluates the likelihood of a particular sample being real data or data produced by the generator. And this arrangement 15 establishes a competitive training environment for both the generator and the discriminator. Next is restricted Boltzmann machine. I will introduce this. RBM is a specialized type of generative stochastic neural network that captures knowledge about the likelihood distribution of its input. These machines compress the visible and hidden nodes, interconnected in a way that enables them to detect deviation by learning the typical behavior of the system. RBM belong to the category of Boltzmann machine, but with limitation on the connections between visible and the hidden layer. This restriction improves efficiency compared to general Boltzmann machine algorithm with techniques like gradient-based contrastive divergence depends on the specific task. RBM can be trained in either a unsupervised or supervised manner, showcase their flexibility. Okay, the next DBN will be introduced. The DBN consists of multiple layers of latent variables referred to as hidden units within its structure. These layers are interconnected, but the units within each layer are not directly connected. The remarkable aspect of DBN is its ability to acquire knowledge about the probabilistic reconstruction of input data in an unsupervised manner. Once it has been trained using a set of examples. As a result, the layers within the network serve as detectors for extracting meaningful features. After this initial learning phase, a DBN can undergo supervised training to fulfill classification tasks. DBN also consists of simple unsupervised networks such as RBMS or autoencoder AEC. Next is a DCNN, deep convolutional neural network. DCNN has differentiated themselves from traditional CNN convolutional neural network by incorporating a higher number of hidden layers, thereby augmenting feature extraction capabilities and evaluating prediction accuracy within the realm of deep learning. DCNNs consist of two variations. First, one involves adding more hidden layers, while the other focused on increasing the total number of nodes within each hidden layer. These variants are frequently employed in computer vision, such as object localization detection and image classification. DCNN functions as supervised learning algorithm that utilize the raw data to identify distinctive features for classification purposes. This stands in contrast to alternative machine learning techniques that necessitate the prior selection of input features or attributes. And I think the most important one is CNN. CNN have played a vital role in driving the remarkable advancement of computer vision in recent years. I think most of people knowing the CNN have emerged as a revolutionary architecture paradise that has completely transformed image recognition, object detection, and image segmentation task, and so on. So I think I will pass this this topic. And it is also known that CNN will involve some the layers. First, for the convolutional layer, pooling layer, mass pooling layer has mass pooling, average pooling, and finally is the fully connected layer, and so on. So I think that I will pass also this page. Okay, I think I will briefly introduce some of the different types of CNN architecture. First, the LeNet. LeNet introduced in 1998 stands as a pioneering convolutional neural network, and it's introduced by Young, Leaken, Christopher Briggers, and it serves as a seminal model in the realm of deep learning, often referred to as the hello world of this field. So it is the best. It is the most simplest model for the CNN. And also next is AlexNet. AlexNet is also on type of the CNN. Fundamental the AlexNet is very popular in the image recognition, object detection, and so on. Next, I introduce the ZFNet. ZFNet, which is a CNN architecture devised by Rob Burgers and Mason Jader, emerged in the 2013 competition. In the ILS VRC 2012 classification task, ZipNet outperformed AlexNet despite having a few parameters. It achieved impressive accuracy even when trained with only 1,000 images per class. So ZipNet improved upon the foundation laid by AlexNet by making significant adjustment to key architectural hyperparameters. And I think the next is the GoogleNet. GoogleNet CNN architecture outperformed the previous winner like AlexNet and ZipNet. It's the most great secure GoogleNet architect achieved its tips by utilizing unique techniques such as one-by-one convolutions and the global average polling. While it requires a high amount of computational resources, this architecture incorporates pooling layers that effectively eliminated spatial redundancy during training, causing the total number of parameters to drop that need to be learned. Okay, next is the VGGNet. VGGNet, the team leader is by Andrew Liesman and Karen Simmons, Oxford University. Oxford University developed in VGGN is an impressive architecture consisting of 16 layers and boasting a struggle a stature 95 million parameters. It was trained using an extensive dataset containing over 1 billion image classified into 1,000 different classes. ResNet. ResNet is an extraordinary residue net accomplished an incredible milestone. This remarkable feat was made possible by its impressive depth, for boasting 152 layers and over 1 million parameters. Even its extensive architecture using 32 GPUs, training ResNet using the ILSV RC 2015 dataset would have demanded more than 40 days. Highlighting its classification as a deep network, ResNet exhibits the versatile nature of convolutional neural network by effectively resulting natural language processing tasks such as machine comprehension and sentence comprehension. Despite being primarily used for image classification with numerous classes. Next is mobile nets, which a family of CNN architecture designed to efficiently deployed on mobile gadgets for image object detection and classification tasks with least amount of latency. And mobiles created by Angelo G. Grant. Okay. I think next I introduce the Inception V version 3. This is an important neural network architecture based on CNN, which is a cutting-edge architecture for convolutional neural network. It builds upon the success of its predecessor from Inception version 1 to now go to the Inception version 4 or 5. And one of the key features of Inception version 3 is its utilization of the Inception module, which is designed to capture multi-scale features effectively. The utilization of parallel convolutional layer with different filter sizes in this module allows the network to capture fine-grained detail and high-level abstract features concurrently. Okay, CNN. About the CNN application, I think I just a few introduction. It is known that application of the CNN model, mostly in object detection and image classification, and it also used in semantic segmentation. Right. So also we can use the CNN to develop the image generation and such as medical imaging and NLP, natural language processing, and video analysis, also recommendation systems, and something about robotics application, and also such as the augmented reality or AR applications by recognizing and tracking objects, improving sense, understanding, and enhancing user experience. These applications demonstrate versatility and the effectiveness of CNN across various domains, showcase their immense potential in solving complex visual. Okay, next, I think I will have shown everybody a project developed from my laboratory. Most of the article name of the project, we call it experimental applying acoustic emission to fault diagnosis and prediction of autonomous devices. In this project, I will have some introductions and the motivation and the objective of the article, and also introduce some the theoretical basis and also the experimental stages. And the final, I will have some of the results and discussion about this project. Okay. In the it is known that industrial development is gradually transforming toward intelligent autonomous by the development trend of Industry 4.0. The mechanical system for the diagnosis by using of prevention techniques is urgent and necessary. Thus, areas of abnormal diagnosis and prediction technologies based on artificial AI are extensively proposed in this article. Moreover, in this article, we're using of the most acoustic information machine learning system to collect acoustic information, which can in-depth acknowledge system health and prevent from system faults. And this developed system used a deep learning model to analyze and combine input of static, acoustic feature data. Besides, there is a diagnostic model developed with AI learning methods can be used for decision-making problem. And the development of industry summarized the process of mechanical automation. In Industry 1.0, human mechanization, 2.0 electrification, and 3.0 automation will be realized. With the better development of artificial intelligence, the autonomy of machine intelligence becomes no longer far away. And the method in the literature decomposes the variation signal in the multi-IMF. There is also some concept about tiny machine learning that is inspired not only to be accurate, but also to promote SGD globally. So in this project, also extract the entropy of each frame of the speech signal and normalize each value as the feature of the sound source signal in this paper, in this article. In order to complete the signal collection and application, when designing the circuit, the problems of power line communication and the electromagnetic compatibility must be taken into account when designing the circuit. Okay, next is some theoretical basis. This project adopts the recording to take audio. Data information are shown in this table. We use the experimental recording Audacity software to record. The recording information is modulated by the software. Put the motor recording audio into the voice training. And finally, preprocessing the audio, so the audio frame is a self-state value. And all the theoretical basis, we can see the pictures. The information is separated, and the time domain signal is converted into a frequency domain signal using the fast Fourier transform formula and analyzed on the spectrum. And in the project, we use the MFCC, male frequency spectral coefficient. We call it MFCC, makes it easier to distinguish and make labels. With good label data, machine learning can be used to put into the learning model, and the model can be obtained. Once the model is obtained, we find that the training result is as high as 94.2%. Okay, this picture shows us all the algorithm and the flow charts. This flow chart based on Python, we import the TensorFlow software as a driving architectural platform. And this project uses Jupyter Notebook and Google Colab as the software architecture platform. The Cyberlink model uses CNN architecture to compare the frequency spectrum after fast Fourier transform conversion of the sound frequency as its judgment standard. And this article takes abnormal sound detection as the main goal and divides the required work into 5 major themes. And then use the CT program for the required work. Respectively use WAV files for the audio path and marks them for easy authorization. Next, I show you the circuit architecture. First, this architecture is based on Arduino 33 Blue modules as the enlightenment of the research. In order to prevent the shortage of nano module, the self-developed module are used to replace the nano module. The architecture of the Arduino platform encounters problems during circuit board layout, such as electromagnetic interference, circuit analysis, excessive or low impedance, and the hardware implementation after layout. Okay, and I show you the second stage. All the MFCC are collected from after the fast Fourier transform, and we collect all the sound frame from the original sound from the machine. So we can use this use these images to do the recognition. So in this project, as a detection of abnormal noise or motor, it's required to make judgment on the motor side and predict the state of the motor. So this is all the full scheme about the motor translator. And this is in the final we set up all the architecture. So in the feature we can see about here we have a transformation, and this is the motor. So we use a controller to control the motor. Then let's the let the some object can move left and the right. So we have sound headphone put here, then to correct the sound. And I think I introduced some about the brief results and the discussion. This project is based on the frequency of audio data as the basis. Through faster Fourier transform, the visual analysis of the data can be used to help the label data, and also use the MFCC to put into the computer training model. And maybe you have the question about how to set up the sound frequency. It can be seen that the frequency of the test model is mostly concentrated from 16 to 120 Hertz. And this feature is used as an important basis for the preposition label that must be done before returning. And it can also confirm whether the recorded data is of high quality. And in this study, it is based on frequency of audio data as the basis of analysis, and use the MFCC to put into the computer training model so that the computer can learn data through the graphical computer after MFCC. Also, we can we find about the results from the build framework, which illustrate the accuracy of audio judgment can reach about 55%, and the accuracy of judgment for motor audio imaging here cannot reach 20% at the current stage. Okay, finally, I have the conclusion. In this project, it focuses on the smart factory environment, but the current working method is aimed at recording sound from a single motor in a simple environment. And in this project, we put the motor into a closed environment for audio collection. The audio collected in this project is more pure. So more pure is in a closed environment, but it also causes a lot of errors in the test. Because the environment is too clean, the test becomes a major obstacle in the test of this project. In order to avoid this disadvantage, it can be used as a practical method for references when adding a lot of noise to simulate the situation in the factor when the environment is required for training or in the test stage. Yes. So I think the implementation can achieve the goal we have set in the beginning, and it can control the efficiency and reducing the production rate. Okay, thank you for your listening.
Thank you so much, sir, Dr. Joy Long Song Chen, for your insightful and enlightening session on emerging trends and real-time applications. Thank you, sir, for your valuable presence and insights. Thank you. Now it's time for vote of thanks. I welcome Mrs. Radhalakshmi, Assistant Professor of Computer Science and Engineering, Kamaraj College, to deliver vote of thanks. Ma'am, please.
John sir, this is Janani going to give vote of thanks.
Yes, ma'am, please.
So very good afternoon, everyone. My special thanks to Mr. C.A. V.K. Dharmarajan, Secretary of Kamaraj College of Engineering and Technology, Virudhunagar, for his constant support and encouragement. Then to our respected principal, Dr. S. Sindil, for his guidance, and to Dr. A. Meenakshi, Head of the Department of Computer Science and Engineering, for her leadership throughout this international technical colloquium. A huge thank you to all our distinguished resource persons whose expertise and knowledge have deeply enriched our learning over the past 5 days. I also extend my sincere appreciation to the entire organizing committee, the co-coordinators, and all the faculty members involved in making this event a grand success. Your dedication and hard work have been the backbone of this colloquium. Lastly, a special thank you to all the participants who have joined us throughout these 5 days. Your active involvement, curiosity, and enthusiasm made this event all the more special. Before we officially conclude this wonderful event, I would like to extend a heartfelt thanks to each and every
Jenny, ma'am. Okay. Okay. Thanks for your vote of thanks, ma'am. And with that, we come to the official conclusion of the International Technical Colloquium. It has been an incredible journey filled with knowledge sharing, collaboration, and insights into the cutting edge of technology. We hope you take away valuable lessons and ideas that will inspire your future endeavors. Thank you all for being a part of this prestigious event, and we wish you the very best in your academic and professional pursuits. Goodbye and take care. Thank you.
thank you.
Now we are studying cyclic reality check (CRC). It is a technique to detect errors. But before we proceed, you have to understand few things. First one is exclusive OR. So how does exclusive OR works? Let's say we have these bits. If both bits are 0, the result will be 0. If one bit is 1 and another is 0, the result will be 1. Same here. And if both bits are 1, the result will be 0. This is how the power works. Now devise it. Both parties, sender and receiver, will agree on the same divisor. Let's say we have a divisor 1, 0, 0, 1. And second thing, the degree of divisor will be the size of CRC. Now it's a primary, so what is this degree? 0, 1, 2, 3. So degree is 3. Size of CRC will be 3. Divisor can be any code, but both parties will agree on 0. Now let's say we have a data.
हाँ सर हाँ 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 सर पढ़ दो मैंने पढ़ Jing naman. Ada ating kaya. एक मॅडम नितीन पाटील सर असताना मी कधी जायचं चहा प्यायला झाली ती लोक सांगायचे तेच करा सर चला आपण चहा प्यायला इथं रिवाज आहे. तुम्हाला लेक्चर अगोदर आला 4-5 मिनिटं लेक्चर आता लेक्चर आल्यानंतर लेटर दे आणि लेटर वाटल्यास मी नसेल व्हॉट्सअप संदीप बरं चालू आहे ना काय झालं काय म्हणतात तुला चांगलं प्रिपरेशन करायचं असं नाही करायचं
आता आमच्या बॅगला 1 वर्ष चांगला प्रॉफिट आहे आता एवढं 6 महिने मिळत गव्हर्नमेंट जॉब अजून जास्त लक्ष होतं आपण
मॅथचा हिशोब झाला
रिटर्न गेला कारण की काही समजत नव्हतं काय आहेत की नाही आहेत मग मी
त्यामुळे सिरियस पण झालं ते फिलिंग तेव्हा जातं तो हा आता कन्फर्म आलो आणि तेव्हा ते अटेंड करायला मजा पण येते तेव्हा चांगला रेस्ट लक्ष द्यायचं पण तो काढून घ्यायचा पण निघाला ना मग आता पण नेक्स्ट अटेंड आहे का तुम्हाला
आता रिटेक झाल्यानंतर
नाही करून घ्यायचं जोर लावायचं चांगला
आता करावं लागेल
चल
Good morning.